This video to show you how to use my Python program. I'm probably going to be on the road right now, so I've decided to make a video instead because I can't make today's meeting. So I'm going to show you how to use the program called Pydic.py. So I have 5 images here inside a folder called test. You see on the right here, you see the JPEGs, and on the left you see the JPEGs. These are the same files. And they're started 1, 2, 3, 4, 5. 1 is the first one, and 5 is the 5th frame. It reads the numbers like that, so whatever images you put in, number them. And to run this program, all you do is cd into test, and then python 3, pydic.py. Run that, and in a few seconds, it will finish processing all 5 of them. There. And you'll see that a new folder appears over here that has a whole bunch of information. The most important things that you probably need are the CSV files. Fen can answer information about how to make use of these files. But as of right now, just know that these are the files that have all the things that you need inside of them. There are parameters that you can use and change inside of pydic.py. And you can pass those parameters in as a dictionary, which is an argument that you pass to the program. I'll show a quick example of that in a few seconds. But right now, just know that I took pydic.py and I cd'd into the directory of the images that I wanted to analyze, and I just ran it with no arguments. And this is a superset of all the data you'll need. This data here, as you can see, is, well, I guess you can't see it, but it doesn't discriminate on where the face is. This just does the entire image, so you're free to discard any data that you don't need. If you don't pass in any arguments, it will just do the entire image and get optical flow on an entire grid that spans across the entire image, as opposed to just getting a grid that spans the face. Here's a displacement map. Here's what I mean, right? So it's calculating optical flow for the entire image, including everything in the background. You might not need that. It makes things slower. But besides the performance penalty, if you don't mind the performance penalty, you can always just chop off the parts you don't need in the end. And that makes using this program a little bit simpler if you're going to automate this. And here's the grid outputs, because it also outputs visualizations for you. You can see that it saw how his face moved in different places. And we can see another visualization of the same optical flow field. Fan has created software that can, an IPO notebook file, which can turn these CSV files in conjunction with these images to make heat maps. These are the heat maps that you see in the paper. These preview outputs, while useful for debugging, are not the same visualizations that we use in the paper. So if you need those, go to Fen, he'll have the software for that. I'm going to go into the last detail, which is showing you how to use this as a library. So if you, instead of using the command line, wanted to use this as a library, there's a function over here called runDisk. You just import pydic.py, and then you use the runDisk function. The runDisk function has a few input parameters, the most important of which is folder path, which by default is the path of the directory that you're in, which is why you could just run this program. Other parameters include the window size, which in our paper we used 85 pixels, and the grid size, which we used 20 pixels. These are the moving window sizes. And the area of interest, you can either use all, which is by definition all parts of the image, or you can specify a rectangle. So if you only want to process part of the image, right, because remember how these images, like, we're processing all of this. We only really need between here and here. Well, let's say this pixel over here is pixel, because it's down a little bit and to the right a little bit, so I would say that this pixel is maybe 100, 400, and the bottom right is maybe 600, 800. We would want to draw a rectangle between this point and this point to isolate his face, so between 100, 200, and 600, 800. If we wanted to do that, we would, instead of passing a string that says all, we could run disk with an argument that looks like this. And then it will only calculate the area of interest. You see I've specified 2 points, which specifies the area of that rectangle. If you turn the save images parameter to false, then none of these will be written. As it turns out, these actually take a lot of space. You can see that these are PNG files, and that these are JPEG files, so I'm gonna quickly show you a histogram of what that looks like here. You can see that 75% of the memory in this folder is actually going towards the PNGs. So if you want to cut down on storage space on your hard drive, you can set save images to false, and then it will only output the CSVs. That's pretty much all there is to it. I actually created the ability to change these parameters inside of calling it from a command line, but I'm thinking that's actually not that important to do, because you could just import this as a Python library and use run disk. So for example, if I go ahead and I clear all of these outputs here, alright, so I've cleared all the outputs and all I have is pydic.py and the test folder. Instead of calling it from the command line, what I could also do is just import Pydic. Actually, let's make sure I'm in the right folder. I am not in the right folder. I need to go up one. Okay. I'm in the right place now. I could just do import Pydic. And then call Pydic dot run disk of the test folder, which is the folder path. And in a few seconds, you should see the same output that you did when we run it from the command line, except the difference is this one is being called from a Python program. And that's all I wanted to show you.